Hey everybody, I couldn't find my original video on this, so in my garage under quarantining here, I'm going to go over these. So, what is a mole? So, a mole is a number, it's just a big number 6.02 times 10 to the 23 things. In chemistry, those things are usually atoms or molecules, particles, but that's what they are. So it's just that really big number. So it's what's a mole? Also known as Avogadro's number. Avogadro. Molar mass. Well, molar mass is just how many grams in 1 mole of a material. And one thing that's so nice about the periodic table is that when you look at the periodic table, let's say you've got helium here with a 4.0. Okay, this number right here converts directly into molar mass. So helium's molar mass is going to be 4 grams per mole. Okay. What is molar mass? What is a molar mass related to atomic mass? I think that was supposed to be how is it? So how is it related? Well, I just showed you. Molar mass here is, we find it from the atomic mass. So let's see. Atomic mass gives us a direct, that should be conversion, to grams per mole. It's really nice. It's one of the things that just makes the periodic table so good. Let me see if I can zoom this in a little more. Oh, okay, it won't let me. All right, a mole is equal to, how many liters? Well, if it's at standard temperature and pressure, there's going to be 22.4 liters per 1 mole of gas. That's of a gas. Okay, how many particles? Well, that's going to be Avogadro's number, 6.02 times 10 to the 23 atoms or particles or molecules. And what's the last one there? Grams. Okay, well, the grams are going to be equal to the molar mass. So if the molar mass of something is 4 grams per mole, then you know how many grams you have. Let's see, number 13. How many atoms of carbon are in 1 mole of C3H6? So one of the things I don't know if I probably didn't get a chance to go over with you, when you get a problem like this, remember C3H6, make just the simplest decomposition reaction. If this were to break apart into carbons plus hydrogens, how many would there be? Well, since we've got 3 carbons here, there'd have to be 3 carbon atoms there, and those hydrogens end up being there. So what this tells us, 1 mole of I think that's propane, is going to change into 3 moles of carbon, is made up of 3 moles of carbon and 3 moles of hydrogen. I know, you're kind of like, oh, that's kind of easy. Yeah. What is the mass of 1 mole of carbon? Well, when you look on the periodic table, carbon has a mass of 12. So that's the molar. What's the mass of 1 mole of carbon? 12 grams. What is the molar mass of CO2? Well, let's see, every carbon is 12. We've got 2 times 16 on the oxygens. That's 32. That's going to equal 44 grams per mole for carbon dioxide. Okay, last couple here. How many atoms of carbon are in 0.25 moles of C3H6? How many atoms? Oh, I don't know how to do that. MVP. This is the mole in the middle. How many atoms? Okay, here's atoms. We got to go to there. Are in 0.25 moles. Okay, we're starting there. Oh, it's a one-step conversion. So I'm going to put my given over 1, 0.25 mole of propane, C3H6. Oh, yeah, sorry. I'm going to make sure you can see that. and put that over 1. And since we're going away from the middle of the triangle, anytime you go away from the middle of the MVP triangle, it's a multiplier. And what connects moles to down here is going to be Avogadro's number. So we're going to say 1 mole of C3H6 is 6.02 times 10 to the 23 molecules of C3H8. So let's see. Oh, darn, I did not bring my calculator with me. Let's see. We basically, what we've got to do is we've got to find out what is 1/4 of Avogadro's number. So shoot, half of 6 is 3. Half of 3, the answer is going to be around 1.5 times 10 to the, I'm pretty sure, I think it's going to be 23. Sorry, I don't have my, let's see if we do, because we're multiplying by that, which is basically you're just taking 1, so half would be, yeah, I think it's just going to be 1.5 times 10. You verify in your calculators. How do you set up a conversion, whether it's stoichiometry or anything else? You put the given in the problem over 1. Doesn't matter what the conversion is. Then you multiply, you turn this into a fraction. Now you multiply by your conversion factor fractions in such a way that your units, okay, maybe your given is like 102 zogs, whatever a zog is, and we happen to know that every 10 zogs is 22 blips, BL. Okay, so if we want to convert 102 zogs into blips, we find the appropriate conversion factor. And if we can cancel zog with zog, we know that, let's see, 10, okay, you can do the math on that. But the basic idea is the given over 1, and you set up either, if it's a conversion factor, for most of our stoichiometry problems, a lot of them, the big ones, you're starting maybe with grams, and then you're converting it to moles. And then the moles, you're doing the mole ratio, and then you're converting it to something else. All right, that's it.